IVT. What is IVT? It's the intermediate value theorem. The intermediate value theorem tells us that if we want to get from one value of y to another value of y on a continuous function, we have to pass all of the values of y to get there. Well, it's obvious you can't get from f of a to f of b without crossing k. IVT, intermediate value theorem. Know it by name. The intermediate value theorem tells us why we have to be a continuous curve if we're connecting from one point to another. Even if I'm going up and down trying to get there, I can't get to this value of y up here without crossing every value of y between it. This is why it's important to know when we have continuities, a continuous function. Intermediate value theorem. One way that we can use this is in a problem like this. Is there any real number exactly one less than its cube? Well, to solve this, we should set up an equation. So, a real number, x, being one less than its cube, x cubed minus 1. If we solve this, set it all equal to 0, then all we have to do is graph it and ask, where does the function equal to 0? Now, it might not be very easy to solve this, but since the question asks if there is any real number, not what the number is, all we need to show is that there is a value. So for example, if I think of this as the equation y is equal to x cubed minus x minus 1, and I plug in x equals 0, I'm going to get y equals negative 1. In fact, I'm going to get negative values everywhere on this side. If I plug in a number like 2, I'm going to get a positive value, so all my values are positive over here. So I know that going from 0 to 2, I have to have a change in sign. It doesn't matter then where the 0 is. All I need to know is that I have a change from negative to positive. That guarantees that I pass through 0. IVT, intermediate value theorem. Another theorem that we have dealing with continuity is this one here. If we want to look at a composite function, so basically I have a function inside of another function, we know that it's continuous if its parts are also continuous. So here I have f. If it's continuous and it's inside g, which is also always continuous, then I will know that the composite is continuous. For example, I have an absolute value function. So if I think of that as my outside function, I do know that the absolute value function is continuous because the graph looks like this, and we should be familiar with that graph. I can plug in any number and it will be continuous. On the inside, I've got a lot of parts, but if we look at each one of the parts, we know that x is continuous for all real numbers. We know the sign is continuous for all real numbers. We can see that our denominator here, since it's never going to give us a 0 in the denominator, it's also continuous for all real numbers. So we can see that f is continuous for all real numbers. As a result, if I put f on the inside of g, I have a continuous function inside of another continuous function. Therefore, my composite is also continuous for all real numbers, showing this equation right here is continuous for all real numbers.